Welcome back to the hyperbolic coding chamber. We are back once again to battle the LeetCode gods. And fortunately, the seasons of holidays are almost upon us, but even more fortunately, we have some lovely comments from our local fellow professional computer touchers. From the Yum Dog, with a very questionable profile picture now that I'm taking a closer look. What background music is this? Assuming it's a mix but timestamp. It's actually a random no copyright playlist that I found like 10 seconds before that stream or that video yesterday. So that is what that is. It's actually got some good jammers in there. So a couple of jammers, shall we? And then from the legendary Ice Cream Man 1131337 with the philosophical reflections of the tennis ball. Okay, what the tennis ball actually represents is actually okay. But this comment says, if you do these in one take, you might as well just stream. True. Yeah, I was thinking about streaming, so maybe that's what we'll do. Fortunately, we have a good bit of time coming up next, so starting Thursday will be off, and there's been a lot of work. There's just been a lot of work at work, so it's been a little bit difficult for these longer sessions. I'm trying to finish something before break, but it's just very annoyingly difficult, which is unfortunate. But hopefully there's some reward coming at the end of that. But maybe starting Thursday we'll get a chance to kick off a stream. I'm not exactly certain if it'll be on Twitch or on YouTube. It's unclear which it should be on, but maybe maybe we'll do Twitch. But yeah, maybe that could be cool, but we shall see. But yeah, we must take over. Maybe we'll start doing it on Twitch, and this is the way we usurp our way into the organization. And then from there, we'll have access to the code base, the database, and from there, it's game over. So we pretty much have every big top tech executive in the Discord now. So if we do it in the Discord, it'll just be a matter of time before we've taken over the planet. So maybe that'll be the wave. Maybe that's what we'll do. It'll probably just be a lot of game dev, but maybe we'll mix in LeetCode. So maybe we'll just do it there, and then we'll post the video as a VOD afterwards. But that we'll have to see. But that being said, we're likely going to do a shorter session today, and yeah, maybe I'll put some poll in the Discord to see if what streaming format makes sense or what time makes the best sense. But that is likely what will happen following, and then yeah, we're likely to do a shorter session today, so we're probably going to do 30 minutes. But don't forget, you should definitely join the Hyperbolic Coding Chamber, which is a chamber designed purely for programming. So you have to join this chamber because we just had Drake just dropped Jumbotron Poppin'. We had him in the Discord. He was in the VC with Elon and the gang. We had also a ton of very, very cool faces. So yeah, you're going to want to be in the Discord for when these things happen. Yeah, we had Elizabeth Olsen in Discord as well earlier this week. So people were just talking shop, talking about graph algorithms and the underlying DAG structure and dynamic programming problems. So we're going to have a lot of cool guest speakers, so you should definitely join the Discord. And yeah, so we're probably going to do a regular, nice, lethal 30-minute session. And yeah. So we're going to do a shorter session today just because it's been crazy recently. And then we'll probably be back to the regular schedule soon. But consider all the leaves of a binary tree. From left to right order, the values of those leaves form a leaf value sequence. So if we consider all the leaves of a binary tree from left to right, the values of those leaves form a leaf value sequence. For example, in the given tree above, the leaf value sequence is 6, 7, 4, 9, 8. Two binary trees are considered leaf similar if their leaf value sequence is the same. Return true if and only if the two given trees with head nodes root 1 and root 2 are leaf similar. It seems like what they'd like us to do is simply collect all the leaf nodes from both trees and compare the values to be the same. Seems like we could do this in both an n plus n time, where n is the number of nodes within the root tree 1, and m is the number of nodes in root tree 2, and then we could do a linear time comparison to see if the leaf node values are the same. That being the case, what version would best give us that value? We could do a DFS where we go do in order. We could go L, 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 right? We don't have any children, we'd print it, and then we'd go back to N, we'd go R, L, we don't have any children, return it, don't have any children, don't have any children, we go back to 5, right? We'd propagate back up to 3, go right, go left, don't have any children, 9, 8. So I think we could do it with the DFS. So maybe we'll just take a look at that version. I think the one issue being, if we were to add it to our string, we need a way to propagate that value, and one way to do it would just be to do the DFS iteratively. We haven't written an iterative DFS in a long time, so we're just going to use a little bit of a trick where we'll create a DFS where we'll pass in a node, which can be a tree node or null, and then we're going to have an object which we're going to create that's going to have a string s within it, and we're not going to return anything from the DFS. This O object is actually just going to be, we'll just call it sequence. Value is just going to be the string. And then what we can do is just create 2 of these sequence objects that we can pass through at the end, the state will be preserved because the object is passed by reference in JavaScript, which means we'll need 2 objects to hold these values ahead of time, both of which will start at an empty string. You can copy this, make this seek2. You can call it DFS for root 1 with seek1, and do the same thing here with root 2 and sequence 2, and then we can just check, right, return if seek1 dot value equals seek2 dot value. And I think the one thing we'd have to make sure and check is that if two trees are empty, are they still the same? Number of nodes in the tree will at least be 1, so looks like we'll always have at least 1 value to check, and we'll say if the node exists, right, then we're in business. We'd like to now visit our left node, right, passing in the sequence value, right, and then we'd like to do the same thing with the right node, and with in order we'd handle it in the center, right, and we'd say, well, okay, if node dot left right, and not node dot right, and I guess it's kind of fine to do this completely out of order. We could even make this an else case, but it doesn't really matter. We're just going to say seek dot value plus equal node dot val. And I think if we do this, we'll find that we won't print 3, we won't print 5, we'll get to 6. We have no children, we'll add 6 to our sequence, go back up to 5, right? We'd go down right to 2. 2 does not have 2 has both children, so we go down to 7, right? 7 doesn't have the left child, doesn't have the right child, so we do 7, right? Then we'd come back up to 2, right? And neither there's left or right child exist. Come back up to 5, come back up to 3. I think this should work. So we output true, they output false. Now I wonder why they output false. Six two nine eight null null 714 root 2. Oh, we're missing some, actually. I think if you're missing, well, no, to be a leaf node, you can have no children. So both node left and node right must not exist. That's what's true for 6. It's true for 7, 4, 9, and 8. So I'm going to print seek 1, seek 2. Now I wonder if what's happening is an order issue. Yeah, so we're getting the same value for both. I'm now going to copy this value, and if we make a new case, root 2 will be this, root 1 will be this value here. Oh, I see the issue. One node has 71 to trick us, right? It's 671,498. What we actually have here is 6714,498. I never considered that could actually be a problem. What we could do is just create a comma, add a comma value, and that should fix that. That's a really good test case, though. That's an incredible test case, whoever caught that. But yeah, this should run in the linear time of both trees, and then we're just doing a linear comparison at the end. Doesn't seem to be a follow-up, and yeah, I wouldn't say there's a ton here, so we'll stop there for that one. We'll go to we have replace all question marks to avoid consecutive repeating characters. Given a string S containing only lowercase English letters, we have a string S containing only lowercase English letters, and the question mark character, convert all the question mark characters into lowercase letters such that the final string does not contain any consecutive repeating characters. That's an interesting problem. You cannot modify the non-question mark characters. So they shouldn't be repeating. This could be a troublesome problem, but maybe a greedy algorithm will work. It is guaranteed that there are no consecutive repeating characters in the given string except for question marks. Okay, well that might simplify it a little bit. No consecutive repeating. If there are no consecutive repeating characters, what does that mean for us? It means you don't have something like Z question mark Z. Or we don't have anything like ZZ. Oh, they're saying is the string is already, because the goal is to make no consecutive repeating characters. They're saying the string has a solution because what we're given without the question marks does not have any consecutive repeating characters already. Return the final string after all the conversions, possibly 0, have been made. If there is more than one solution, return any of them. can be shown that an answer is always possible with the given constraints. An answer is indeed always possible. I think I know what they want us to do. If it's possible, we'll have to see, but if S's length is capped at 12, okay, it's not capped at 12. So we don't have to do what I think we have to do. I think this means there's probably some greedy solution that somehow interpolates to a correct solution if we can figure out the greedy intuition. If that is the case, what would that be? If we imagine a string like A, question mark, B, C, at any given time there are two potential answers to that answer, because a character is always adjacent to two other characters, its left character and its right character. If that's the case, the answer is always the lowercase English alphabet minus 2. So you have 24 possible options. The problem is when we have 26 question marks. Presumably there's an order that solves this. How can we greedify our solution? We can't just choose the first letter. Actually, wait, we can. They're not saying we can't use any letter more than once. There just can't be any consecutive letters. So even if there are 26 missing letters, we can just pick any number, any letter that is not part of the two adjacent characters. And that should always give us an answer because we have up to 24 possible choices. I think that's fine in the case where there's letters separated by question marks. Now what if we have consecutive question marks? Well, then there might be an ideal solution there. We could have something like A question mark question mark question mark. What if we just say choose a letter that's not A? We choose B. We have to choose a letter that's not C. Between B and C, well, we choose C, and then D, and then E, and then F. It looks like with consecutive question marks, we can just choose whatever letter we want. As long as we don't choose the last letter. As long as we don't choose the last letter. I mean, the bounding of the question mark. So if we have a group of question marks, we have a letter, they'd be surrounded by two letters. Maybe. I think we can choose basically any letters we want. I think it should be fine. So what we'll do is for each letter, we'll just choose a letter that we might have a letter we need to exclude from the set. That letter might exist if the index before our current index is indeed a valid letter. So I think we could do this just from a for loop stance. We'll say R is equal to S. That will spread. We'll modify this array and then join it at the end to return it. We'll iterate through every indice in the array. We'll have an internal array, an internal iteration that we'll call C. Say C is less than 26, C++, and we only want to do this if R sub I equals a question mark. Now if I, and maybe it might just be easier to say, if R sub I does not equal a question mark, then we'll just continue. Right? But other than that, from here, we know that if we're in this for loop, that I is indeed a question mark. Well, if I is a question mark, it's possible that we I think we could code up a greedy solution like we're going to and just run it. But I'd like to think through it before I just make a decision. I'd like to know why this isn't going to work ahead of time. It is possible that if we have 26 consecutive, I didn't even look at the examples for this problem. Yeah, they seem the same. It is possible that given 26 consecutive strings, it is possible for us to generate a sequence of strings within that range, that has no overlapping characters. Now that I'm realizing, it just has to be that there's no consecutive characters. We don't have to worry about the last character. I think you literally can just make certain that the previous index and the following index are not included. Issue being, I think if just coding that logic might be a little bit nonsensical. The previous index, right, let's just say is -1. It's I going to be I minus 1, right? Now that value has to be greater than 0. At most, there can just be 2 characters that we exclude on every iteration. I think the tricky part of logic is figuring out how to make the previous index and forward index, how to know when to include them. We know how to include them, but I mean how to include them in an elegant way. If we just do I minus 1, we have to make sure it's greater than 0. But also that doesn't equal a question mark, which means we need to know a way that it's valid. So we can say if it's valid, right? Then we'll have validity for, we can say that it's not the previous index. Similarly, right, we can assume that it's not the following index either. And if there's ever a case where these are both true, we can place and case 2, then we can just say that r sub I is equal to string, right, dot from car code, and then we can just basically say 64 plus C. Now case 1 has to default to true, right? And we can change case 1 is just going to say that pre-index valid, right, defaults to true. We can also do it like this, I think, right? If, or ternary, I minus 1 is greater than or equal to 0, right? It's a valid index within the array. Additionally, right, and s sub I minus 1 does not equal a question mark, right? Right? Now, all this would mean that it's valid. Otherwise, or this would mean that it's a valid index, right? If both these are true, then it's a valid index. And we can copy this. Actually, false. And we can copy this, and then we can say next index valid, right? It's going to be I plus 1, right, is less than r dot length, right? And I plus 1 does not equal a question mark, right? And then we can say case 1, right, car is not, you can say car is not next index, right? Then we'll update it, right? So now we need to know, right, const car is not pre-index, right? How do we know when the car is not the previous index? Well, the index has to be valid, right? So if previous index is not valid, right, then it's definitely not the previous index, so you're good. right? Or or r sub I minus 1 does not equal car. And I think this should work. So it looks like, I think it's fine, but I also need to just make sure that this goes to lowercase. The one thing I have to do is when we're checking the previous and the forward index, we have to take into account what we just set it to, so we have to change S to R. So I think we'd be good here. There is some logic here that I'm not exactly proud of because we're just stringing together some Boolean expressions, but maybe it's important to do this sometimes. I would say that the worst case time complexity of this is linear time times 26 iterations for each index, assuming that the entire string is all question marks, but I think we should be okay in that sense. I think we should be okay because we usually drop the constants in big O notation, so we can just say that it's going to be linear time where n is the number of characters in the string. Now, we don't have mutable strings in JavaScript, so we probably have to take linear space as well, since we have to allocate local memory by spreading the string into the array. But in languages with mutable strings, we could probably say that this is constant time. I wonder if there's a more elegant solution to this. There's no follow-up. It looks like everyone is basically doing the same thing. So we'll count that as fine there, and then I think we'll be back tomorrow.